welcome to the Stay-at-Home Camperee session on building a balloon barometer. Let's get started. What is a barometer? A barometer helps to predict the weather. A barometer measures air pressure. A rising barometer indicates increasing air pressure, and a falling barometer indicates decreasing pressure. In space, there is nearly a complete vacuum, so air pressure is zero. On Earth, because of the miles of air molecules stacked up and exerting pressure due to the force of gravity, the pressure is about 14.7 pounds per square inch at sea level. The atmosphere refers to the layer of gases which surround the Earth. This layer of gases is often referred to as air and is held by the Earth's gravity. The atmosphere is an integral part of life support on Earth as it absorbs ultraviolet radiation, causes the greenhouse effects, which keeps us warm, and also adjusts the temperature to suit day and night levels. The interesting thing about air pressure is that it is different at different points on the planet and it changes over time. Why might that be true? Just like a hot air balloon, hot air is less dense or lighter than cooler air. Therefore, on any given day, you would expect the air over a desert, for example, to have a lower pressure than the air over an ice cap. And that would be true. These same sort of pressure differences occur all over the planet for various reasons. The pressure differences have a big effect on the weather, so if you know the current air pressure at your house, as well as the pressure trend, you are able to predict certain things about the weather. As a very general rule, a high pressure area will be clear, and a low pressure area will be cloudy and rainy. You can see from this weather map that areas designated with low pressure, the red L, which you can see here and over here, on the East Coast and in the Northwest. Those areas have rain. The high pressure area here in the center of the country has clear skies and sunshine. So how do we build our own balloon barometer? The balloon barometer will need a narrow-necked bottle like this one, a balloon like you might have at a birthday party, and two pans, one with hot water that you can get from your tap, as well as cold water. As you can see here, I have all of my essentials to build the barometer. I have birthday balloons, I have the narrow neck bottle, and I have already attached the balloon to the top of the bottle. I also have a container with hot tap water and another container with cold water. I put a few ice cubes in so you can see the difference. Let's see what happens when I put in the bottle into the hot water. Oh, there you go. As you can see, the air inside the bottle expanded and it caused the balloon to pop up. Now let's put it in the cold water to see what happens to the balloon. This might take a moment. Still watching. So it looks like the balloon is losing a little bit of air. Ah, there it goes. It now collapses. So what did we see just now? With the hot water here, the air inside the bottle, like the Earth, warmed. It got hot. When it started to expand, it filled the balloon and made it stand up. Conversely, when the bottle was placed in the cold water, here, the molecules began to slow down and contract. And that made the molecules come out of the top of the balloon, go back into the bottle. And that becomes a low pressure area. Now that you've seen how to make your own balloon barometer, why don't you give it a try? Thank you.